in this video clip, we want to find, given the polynomial function of degree 4 with rational coefficients which has 3 zeros, and then we want to find out the fourth zero. We already give like 1, 0, 2, 0, 3, 0, a third 0. So what is the fourth 0? Okay. Now, for example, let's look at the example here. I'll give you an example. If we are given an equation x squared plus 2x plus 2 is 0. So then by the quadratic function formula, you have x equals negative b plus minus radical b squared minus 4 times a times c divided by 2a. Okay, and here we know the coefficient of x squared is 1. So then by the formula, we know b is 2, c is 2, and a is 1. So then we shall have a negative 2 plus minus 2 squared minus 4, then times a is 1 times c is 2 divided by 2 times 1. So you shall have a negative 2 plus minus. Inside is 4 minus 8. So you have a negative 4 divided by 2. Okay. Then we got the problem here is negative 2 plus minus 4 is 4 times negative 1 over 2. And then we know 2 squared is 4, so radical 4 is 2. And then we only have a radical negative 1 there. And we do not know what is the value for negative 1. Then we imagine there is a number which is I over 2. 2 plus minus 2 times I over 2. So we imagine there is a number which is negative 1. Okay, because it looks like, any number squared is positive. So then, if you have a radical negative 1, so we will define. It's like what? It's like 2 squared is 4. So radical 4 is 2. Okay. But right now we got a problem you have a some value squared is -1. So then radical -1, we say that's I, because this never happened. This case, any number squared, you always get what? You always get positive. And we have a case like this, how we are going to handle it. Okay, so I'll give you may also know that -2 squared is also 4. Positive negative squared, you always get 4. But there is no number squared, you get -1. So then we assume radical -1 is I. This is called imaginary unit. So imagine unit. And then I want to circle it. That's the new definition, defined. Okay. Yeah. And then we can say that this number is a complex number. And then we say 2 plus minus 2i are complex number. Complex numbers. And then you see, we say 2 minus 2i is a conjugate of 2 plus 2i. And then the two roots, I would say that they appear in pairs. Okay, so you can see if there is a root which is positive 2i, they must have a root which is negative 2i. That's what I meant. Okay. Similarly for this one, if you have a here, let's say, which might be radical 3, then you should have a 2 plus minus 2 times radical 3. So plus minus, okay, radical 3. So anyway, for irrational roots and the complex roots, they appear in pairs. They appear in pairs. Okay. So if you have a square root, here means that radical 2. And then if you have a 6, 4, radical 2 as a root, then the other root will be what? Will be radical 2. Final answer. Okay, so I want to circle it twice. Oh, because again they appear in pairs. 2 minus 2i, if it's a root of the function here, then 2 plus 2i will be the root. If you have a radical 3 here, then plus minus 2 times radical 3 will be appear in pair. So that's basically I want to say. The complex roots appear in pair. And then irrational roots appear in pair. This is the first question. The second question is then the same. Suppose that a polynomial function of degree 4 with rational coefficients has 3 roots. 3 roots. 6, 4, 2i. Then find the other root. So then the other root is what? Is negative 2i. Okay? Because if we have a 2i, we should have another 2. Another one will be negative 2i. The reason, is come from here. 2 positive negative. So the other root is negative 2i. The reason is the complex roots appear in pair. In pair. All right. Look at the third one. The third one, you have roots. One is 2i. Another here, one is 2i. Another is negative 4 minus radical 6. This one means that. Means this one. Okay. Here we have 2 roots. 2i. I wrote here. Another is negative 4 minus negative 4 minus radical 6. We wanted to find other zeros. Actually, the degree is 4, so we should have 4 zeros. Here we have a 1, 0, another 0. So here is we want to find other zeros. There is a S behind it. So other zeros. Okay. Now, again, the reason is the same. The other zeros are negative 2i and the negative 4 plus radical 6. Okay, again, the reason is irrational and the complex roots appear impaired. Okay, so again, negative 4, let's use black one. Negative 4 plus radical 6 is the conjugate of negative 4 minus radical 6. Or you may say negative 4 minus radical 6 is the conjugate of negative 4 plus radical 6. Okay? And here you may also say 2i is the conjugate of negative 2i. Or you may say negative 2i is the conjugate of positive 2i. They appear in pairs. All right. Please review this lecture. I'll see you next time.